Welcome, everybody. Thank you for joining us today. We're thrilled to have you here for the webinar that is going to focus on understanding catalyst and pellet crush testing. But before we dive in, we've got a couple of housekeeping notes I'd like to share with you. Today's session is brought to you by McMason, a proud member of the Physical Properties Testers Group. The PPT Group, for short, is a collective of leading brands in the field of physical properties testing, offering a wide array of solutions for testing tensile and compressive strength, torque, textiles, and the effects of shock and vibration, amongst other parameters. Our sister companies within the PPT Group include Lansmont, James Hill, and Alluris. And for more details about the group or any of the specific brands, please visit the PPT website. We will also share a link to our events page in the chat box for your convenience. Now, focusing just on McMason, we have established technology labs across the US, UK, and Asia, dedicated to supporting our customers with education, proof of concept, and demonstration testing. So should you have any specific needs in physical properties testing, our global team is at your disposal to provide the assistance you require. Let me introduce the team for today's webinar. Moses DeRocha will be our presenter, and I'm Sharon Smorenberg, one of the coordinators. Additionally, we have support staff and partners stationed across Asia, Africa, Europe, and the Americas, ensuring that no matter where you are, we have a local expert ready to support you. As always, we'd like to have a dynamic and engaging webinar, so we encourage you to participate through questions. Feel free to submit any questions you have at any point during the webinar using the question box. We will then address these questions at the Q&A session at the end. This webinar is being recorded for your convenience, and the recording will be sent to you via the email address with which you registered. So you then are able to share it or keep it on file for further reference. But without any further ado, I'll hand it over to Moses for the presentation.
Thanks, Sharon, and thanks everybody for coming to another one of our webinars. So we'll be tackling a few different approaches to catalyst and pellet testing. Again, these will become clearer as we go on, but typically our agenda for today is going to be first an overview of catalyst and pellet testing, including things like why you test, the importance of testing, and then we'll look at single pellet testing, kind of adhering as best as we can to ASTM D4179, and also bulk crush testing in accordance with ASTM D7084-4. Next topic will be selecting the ideal fixtures that are usually used in these types of test applications. We have a live demonstration today, which is always fun. We'll look at the single pellet testing, and we'll look at bulk crush testing, and then we'll look at what we call a multi-single pellet testing, if that makes any sense. So, but we'll see what that looks like in real time. And then, as always, we'll look at some of the factors that affect repeatability and consistency in your testing environment. All right, so why is catalyst and pellet crush testing important? As with most physical properties testing, for research and development to determine product viability, strengths and weaknesses, for quality control, to establish product standards for quality and safety, for production, maintaining product quality and safety. And then in cases where you're supplied goods and you need to check those goods against supplied values, it's used to, the testing is used to verify the aforementioned product quality and safety. So these are some of the ways that the testing is used. There's several different industries that use catalyst and pellet testing. One, automotive and aerospace, in medical and pharmaceutical, in petroleum and oil refinery, in chemical production, environmental, as well as plastics and polymers. So what is the actual test and what does it involve and why is it even done to begin with? Now, catalysts are widely used in industrial processes where yield and time issues are critical to forming a product as soon as possible. They usually deserve the activation energy required for a particular reaction and often speed up the reaction by working at a comparatively lower temperature. And also, to perform efficiently, catalysts do not only need to have excellent absorption properties, but also good physical strength and characteristics. You'll find certain commercial catalysts come in different forms, sizes, and shapes. They'll be either round or cylindrical, pellets, granules, tablets, spheres, rings, and other extrudates. There are also mechanical failure properties that will cause small fragments and fine particles forming, which essentially creates blockages in fluid flow, especially in the oil and gas and oil refinery and petroleum industries. And this is unacceptable, which essentially will cause pressure to drop across the reactor and create other variations in heat transfer. Again, determining the mechanical strength of solid catalysts is therefore key. It's critical for ensuring a reliable and efficient reaction process. Now, because of the brittle nature and the minimal deformation characteristics of most catalysts and pellets, this presents a kind of a critical challenge when testing. For that reason, several different test standards have been developed depending on the type of catalyst or pellet that's being tested to capture, especially the points of deformation or the point of fracture. That way, whether in research and development or in production environments, we have enough information to go on to make sure that the processes are safe and also that we're meeting our own safety and quality standards. Now, the primary test applications are, again, single sample testing that you'll find in ASTM D4179. This is where you're testing just a single pellet. And these are usually, again, compressed until fracture or break, either a side loading, top loading, depending on what the particular sample or product requires. Again, most testing applications for single pellet testing or catalyst testing will involve running the test at a constant rate, compressing until the sample fails or fractures, and then calculating the break force and the average force. And then there is bulk crush testing according to ASTM D7084-4. This, again, similarly, instead of testing the single pellet this time, you again you measure and test a bulk in any cup or circulometer or pod that will hold that quantity, and then you bring down either a compression plate or a plunger, and then apply a known force at a constant rate for 30 seconds. And then at the end of the test, we'll calculate the average force and also the energy or the area under the curve. Now, in practical terms, if you go in kind of strictly according to the testing standard, you're also required to dump the tested product out and then sieve it to see how much of it actually failed and how much of it goes through the sieve. So these are the two main tests that you'd encounter in pellet and catalyst testing. Now, in testing environments where in cases where you're testing single samples, you also want the ability to test as many of them as possible, let's say 100 at a time, instead of having to have an operator always pick and place the single pellets. There is a custom semi-automated solution that has a carousel that allows you to test these multiple samples by running at a constant rate against compress the sample until fracture or break, and then that allows the test to complete, which will rotate to the next sample, repeat the test for as many different samples as you have, whether it's 10 or a dozen or 50 or 100. And then in most of these, especially when you're only looking for just the break force as a value, you should be able to calculate that. So the three types of tests that I've discussed essentially is what we're going to see in our live testing today. And then, as always, we will choose which types of applications, which types of testers and fixtures and so on are best for these types of applications. So now choosing the ideal tester. There's several different types of testers. Again, sometimes if you're looking to just for either for purposes, budgeting purposes or any other challenges, and if you're not able to invest in the ideal equipment, there may be handheld force gauges or just simple motorized testers. However, if you're looking to test specifically to either of the two ASTM standards, and then there are other ASTM standards that allow you to test pellets and catalysts, there are also inherent calculations that should be included in the test report, which using either handheld force gauges or just simple motorized testers do not afford you the ability to do. And so what we always recommend is the software-driven tester, either a force or materials tester. One of the reasons is, one, obviously it's software-driven. It's easy to program. It has high load cell accuracy, has great resolution on the load cell. It also provides you both automatic and custom calculations, which allows you to generate all of the data as required by either testing standards. And system also allows you to generate test reports based on your test results, or in cases where there are additional requirements for data acquisition that the software does not provide, you have data exporting options to allow you to export data either to CSV or to Microsoft Excel to allow you to input additional calculations using the output data. So that's what we would recommend is the software-driven tester. All right, so choosing the ideal fixtures. Obviously, once you select your tester, the next thing is selecting the ideal tester. And this is usually determined by which testing standard you're actually running to or what your actual testing requirements are. So if you're testing single pellets, then obviously a simple stainless steel or aluminum compression plate on the top and the bottom is sufficient, as long as the pellet is not rolling around or moving while it's under compressive load. And those plates can be either round or square. And then in certain cases where you have uneven surfaces on your samples, you might choose a self-leveling compression plate over a static one. In cases where you're testing bulk, we always recommend using a circulometer or a cup or a pod with a plunger. And those again can either be steel or aluminum. And then your compression plate or the plunger can be either static or self-leveling. Now, one of the requirements here is also, especially when you're testing multiple batches of samples, the requirement or the recommendation is to have pods or samples or fixture assemblies that will allow you to empty the tested samples quickly if you need to go to the next step of the test, which is more of a physical test than anything, where you pour the tested samples into a sieve to sieve it to see how much of it passes through the sieve. And so having samples, fixtures that allow you to easily discard the tested samples is critical to the testing application. And then I did mention the third type of test, which is the custom type of test. And this usually involves having a special fixture, a custom fixture that allows you to move from one sample to another between intervals to perform your crush test to measure brake force. So these are the types of fixtures that you usually would find in any testing environment that's subscribing to either single pellet or bulk crush testing. All right, so without further ado, that's essentially all there is to capture in the overview. Now, the reason this looks a little bit abridged is because we have 3 different applications to go through, and also any one of these testing applications can be its own webinar, and we're kind of condensing them for purposes of time and so on. And we're also hoping that at the end of the presentation, we might actually have some questions. So, all right, let me share my webcam here and hopefully walk you all through what we are looking at. So The first setup is the rotating base plate, the custom plate that allows you to test multiple samples. But for starters, we're also going to use that to test the single pellet. And then we'll kind of move over to the rotation once we're done with that. I am also going to share the software screen so we can kind of quickly go over the test configuration. Now, the test that we've written are kind of loosely based on the testing standard. However, we do capture all of the essential parts of it. Again, for purposes of time and this presentation, we've kind of abridged things a little bit. So all the test is doing here is going to ASTM D4179. And again, in the testing operations, all we're asking it to do is 0, run to a preload, and then apply. The standard calls for between 1 and 10 pounds per second. We've chosen to apply 2 pounds per second for purposes of our demo until the test completes. And we're going to run this to a maximum of 20 pounds or break whichever happens first. So as you're applying 2 pounds per second, your target load is 20 pounds or break whichever comes first. Once the test completes, Crosshead returns home. And the only other thing I'm going to change here is just take a higher data capture rate or data acquisition rate or sampling rate, so we capture the break value as soon as it occurs. It essentially makes the break detection a little bit more sensitive. And then in our test results, we're looking for the maximum, which we're calling our break force here. Now, in instances where you also have pass or fail criteria for any particular product A, the software will allow you to enter those values. Either if you only needed to meet a minimum, you can enable minimum, enter the value, or if you did not want to exceed a certain maximum, then you can enable that and enter that whatever the maximum is, or in most instances, you can just enable both and essentially create a range. I don't have any values for now, so we can just disable it. The reason being, you can also do this on the front end during testing. The next value we're looking for is simply the average force over the entire test duration. And then we're also looking for the area under the curve or the energy, so to speak. We've also configured a test report. So if we're sending products out, we're supplying, or we were need for auditing purposes, if we needed to create a test report that indicates, hey, this batch that came in from supplier A was verified, tested, here's a testing report, and so on, we could do that. So that's pretty much all that goes into setting up this particular test for a single pellet crush. So without further ado, I am sure you all are dying to see what this looks like. So when you log into the software as an operator, all you do is just click on that and it will bring you to the live test mode. I am going to change the contrast a little bit so we see the traces a little better. And at this point, we are ready to test. So what I'm going to do here is hit start. So the plunger is going to come down, touch the top of the sample. If you can still see my webcam. Once it touches, it's going to proceed to apply 2 pounds per second until the sample breaks, and then it's going to back off. That's end of test. And then all the operator has to do, push home. And that essentially just moved to the next position. But we'll move the tablet along as we see fit. But now, just gonna just drop second sample in and then push start. It's gonna come down, touch, compress, break. Okay, not sure what happened there. So we'll take these two out. Those are effectively broken. We'll put a third one in. Okay, that's our break. And return home. There we go. So we'll look, we can, again, this is why you test this, kind of an anomaly on test 2. Once I just tested 3 samples for our demo here, once the test samples are completed, you can go over to the test results tab, which will essentially tell you pretty much everything you've asked for as far as calculation. So the break force, it's catching that at about 12.8 pounds. So that's where we're seeing that break force for test sample 1. And then for sample 2, that was the anomaly. So there's some funny business going on there. But again, this is why you test. You also want to catch any of these anomalies as and when they do occur. Sample 3 did test and complete, and we can see that right up there. And then we did also measure the average crush across the entire spectrum. If you can see my screen, that would be that red area, which is measuring about 7.4 pounds. That's the average. And it's seeing about 8.2 pounds in sample 3. And then we also wanted to look at the area under the curve, or the energy, and that's about 4 pounds per millimeter, as based on the samples that we're testing. So this is a typical single pellet crush, where you're testing them one by one by one. There are also instances where, you know, an end user may say, you know what, I'm only interested in just, you know, just the break force value and nothing else. And every shift has to test, every shift has to test, you know, 50 samples. Then those are the instances where we would recommend going the multiple sample tests using the rotating plate. So that's what we're going to try to do here. Hopefully my system is friendly. It wasn't friendly last night when we set up. Hopefully it will be friendly this time. So essentially all this does is just automatically rotate to the next sample and the next sample and the next sample until all the samples are tested. And it also relies on a few different setting parameters, the most important of which is the interval between tests. So you can set that, say, you know, I need a test run every 1 second or 2 seconds. And that once you start a test, the system will prompt the operator for how many total samples they're testing. We currently have 5 samples. So I am going to exit and quickly walk you through the test procedure. So this is the pellet break test, which is essentially our rotating sample, and walk you through what that looks like. So it's going to be very similar to what we just did, except a few different parameters. Now, there are also additional parameters for there's certain test standards we've done in the past where they'll say, oh, you know what, you need to measure the length of the sample to use that value to calculate additional data and so on. All of that is possible in the software. Again, as I said, any of these 3 different test applications can be their own 1-hour webinar, but for purposes of time, we wanted to kind of just, this is more of an introductory webinar than anything. So in the operations, as you can see here, it's a very simple test. So this time, instead of using a load rating where we run at the previous 2 pounds per second, this time we're running at to a break at 10 millimeters per minute. So we're going to come down, touch on, and then run until a break condition is detected. At that point, the probe will retract, and then the plate will spin to the next position or the next sample, come down, do that. And then on the bottom right, we're asking it, we've turned on the automation, and we're asking it to repeat that every 2 seconds. So let me just reduce that to every 1 second, so we're not sitting here and waiting and waiting and waiting. And then obviously in the test results, we're only looking for the break force. And that's it. Again, you can apply your pass or fail criteria depending on whatever your own supplier or your own production values actually call for. So again, we've also configured a test report, and we'll look at that momentarily. So that's all there is to the test configuration. So again, once an operator logs in, all they have to do is select the appropriate test. In this case, this is the pellet break test. And again, change the contrast just a little bit so we see the traces better. Let me click that one more time. There we go. So at this point, we hit start. System will ask how many samples we would like to run, because we've already activated the automation. So we'll say I need to run a total of 5 samples, go. So now it's going to come down, touch the top, run to a break, and then automatically move to the next position. So next position. Okay, so it's coming down. That's our break. Next position. 1 second, come down. Okay, something happened in there. All right, so that's essentially it. Now, again, this is just loosely based. I had to use what I had here. So, but that essentially shows you how we use that rotating table. And again, it has 100 spaces. So you could essentially have 100 in there. Now, depending on the shape of your catalyst or pellets, the notches that you're looking at, we can actually modify those to fit the spaces so they're not moving around. As you can tell, these are rectangular notches, and you're using, round samples. So there's a little bit of, expectation there that everything will stay in place. But ideally, for round samples or spherical samples, we would use round placeholders or notches on that plate, which would prevent that. So I want to kind of show all of this to you. That way, when we discuss some of the factors that can affect consistency and repeatability in testing, we can touch on that topic as well. But as far as the tests are concerned, that one, again, just an anomaly. Something happened there. But test 2, it's about 16 pounds break force. Test number 3, about 13 pounds. Test, it's about 12 pounds. And something else happened here as well. Now, usually when we do these demos, I don't want any of these values to be written in stone. It's more of the proof of concept than anything. In an ideal world, if you wanted to see exactly what the values are, these are some of the times that we could arrange a virtual demo where you would send us samples, we would match them up with the appropriate fixtures, and then we would do that, and you'd see some data that you can actually analyze. But everything we're doing here is just a proof of concept to just show you how these applications are done. So again, these samples can be spherical, they can be cylindrical, and I've actually tested samples where they wanted you to stand the sample up. So those are instances where we would have to change the different notches on the plate to make sure they accommodate that as well. But the plate itself is designed to move to the next position as soon as each test is completed. And this can be repeated for the ASTM D4179 as well, where it uses the load rating. So the next test is the bulk crush test. And if you give me a second, I'm just going to move my camera over to the setup. So this is essentially the setup we have. I do have some catalyst that we can't use. And one of the things we will discuss in establishing consistent and repeatable testing environment is being able to measure appropriately the same sample size for each test. I did also mention the ease of removing and discarding samples. So that obviously does come off. We're just going to take a sample size here and we'll fill that. So that's our sample size. And we'll go ahead, place the sample. And then I'm going to, also wanted to show you what the test report looks like on these tests that we just did. So if you go to report, it should pop up here in just a second. So it will show you pellet break test report. It will have which user was logged in at the time of the testing. It will give you the values, and then it will give you a graph. And then there is an inbuilt PDF driver that allows you to create a PDF test report here. So as you notice here, sample one didn't yield any test results at all. There are additional annotations that you can include. We'll say sample one will just say sample slipped, for example. Right, so that's now included when you generate your test reports. That way, anybody looking at the test report will go, okay, what happened to sample one? You can tell from this as sample one, which is that blue trace, the sample slipped, and that probably would account for why it looks the way it does, a little bit different from the other sample. So that's what the report generation does. As you can see here, you can use the TXT feature to export to a CSV, or you can directly export to Excel, or you can email this to any number of recipients, or you can send it in the cloud if you have partners in a different country in the world and they would like to see the test results. You could use that feature as well. All right. Next is the ASTM D7084 test. Again, if to just quickly go over what the test configuration looks like. In our operations, again, very similar. However, this does call for 10 pounds per second, and then you're going to hold it for 30 seconds. Now, any product like Catalyst under hold kind of have a really interesting reaction when the motor or the crosshead holds that for 30 seconds. So we'll look at that. We'll test just the one sample just so you all see what that test looks like. And then in the test result, we're looking for the maximum force and the area. Now, one of the more important parts of this test is where the sample is dumped into a sieve, and then the operator has to sieve that to see how much of it failed. Is it just 10% of it that failed? Is it 20% of it? And what actually meets your own internal pass or fail or acceptable quality requirements and so on. So that's essentially what that test looks like. So I'm going to go over and we'll run a test to see what that looks like. So here we go. Start that. Here we go. So we're going to set our home position first. That way the plunger knows to return to that home position, because on that previous test, as you can see, there's a different setup. Now, that's also one of the advantages with the testing software, is we're able to accommodate two different testers using the same software and just call them up as we see it, so, or as we need them. So at this point, we'll go ahead and start the test. So plunger is going to come down, touch the surface, continue to compress, maintain 10 pounds per second for 30 seconds, and then it's going to retract. So that's our 30-second hold. And that's our test. It's a pretty cool little test. So in the test results, now even though we're calling this brake force, we should really call it just maximum force than anything. Okay, here we go. Just call this max. And seeing right about there is where it maxed out. And then the area under the curve of the energy is about 23 pounds per millimeter. So again, at this point, all the operator has to do, remove the circulometer, dump it out, grab another scoop, about same sample size, put that in, and then on and on and on, and continue testing. So that's essentially the whole test, pretty much. Hopefully we'll get to discuss any other questions you guys might have. But as far as our presentation, that is the end of our presentation. Now let me bear with me just a second, y'all. Here we go. Okay. So again, so one of the things we do like to discuss during every webinar is one of the critical things, factors that help you establish a consistent and repeatable testing environment. They're always going to be the same. Defining the testing objective, what are we looking for? Depending on which industry you're in, whether it's petroleum or environmental or plastics, we need to determine why we're testing these pellets to begin with. Next thing is to establish the testing standards and requirements. Are we testing to our own in-house testing standard? Are we testing to a specific ASTM standard? Are we testing to an ISO standard or whatever? So this is critical because obviously then that gives you an objective that you're testing for, or how you go about accomplishing whatever the objective is. If we're looking at the structural hardness of the sample, or how the sample reacts under load, or whatever the braking force is, or the point of deformation, or how far it actually crushed before it actually failed. All of those are different sets of data that you could get from a test, but that needs to be defined. And then if you're also testing to specific testing standards, there are also additional calculations that are stipulated by that testing standard. Next step, obviously, is choosing the appropriate testing equipment. Once you select that, as I mentioned here, a lot of the software, using software-driven testers, does the work for you, because the least desirable thing is to have operators guessing what needs to happen next. Because when you've established a standard operating procedure for operators, which we'll be looking at momentarily, the next thing you want is just for the operator to put the sample in, hit that start button, and have everything else happen, in spite of the operator, in order to establish consistent test results. So going hand in hand with your testing equipment, obviously, are the types of grips, fixtures that you would use, or fixture assemblies. So parts of developing an SOP for operators and staff is, one, determining, because what we're trying to do is maintain the same factors for each test application. So we're using the same sample size, especially in bulk crush testing. We're going to put 8 ounces, in the circulometer or the cup each time. We're testing under certain environmental conditions. I believe in one of the testing standards is ASTM-D 7084. All of the testing needs to be completed within 10 minutes, because certain environmental factors might affect how that sample reacts. Maybe if it sits and it's too warm, it might start to cluster together. If it's too cold, it might react in a different way. So the environmental conditions are critical to the testing. And as always, if the data is still inconsistent, it's okay to check the actual product anomalies to determine whatever happened. So these are all again, universally true, regardless of what your testing application is. So at this point, I would like to turn it over to my colleague Sharon for any questions you all might have.
Thank you so much, Moses. As Moses said, if you have not yet put your questions in the question box and you have some that you'd like to submit, please do so now. We already have a few questions. So Moses, I am just quickly gonna start by reading the first one to you. And the first question is, can fatigue testing also be done?
So again, we need to determine what fatigue testing is. In our industry, when we say fatigue testing, we're thinking of bend or flexure testing, or testing we call a life cycle testing, where you continue testing the product until it fails. In other terms, fatigue testing is more than likely also compressing a product to a known load and then holding it for a certain period of time until it fails. Which parts of ASTM D7084 has? It says calls for 30 seconds. Depending on what your own internal requirements are, you could hold it for longer just to see how that product reacts under load, especially if that is something that happens in a real production environment where the product is under load. So if by fatigue testing that's what you mean, then yes, as you can see here, our software allows you to hold that product for up to 2 million seconds. So yeah, so the product can be held at a known deflection or under a known load for a certain amount of time. In our case, up to 2 million seconds. For purposes of our demo, we only chose 30 seconds, which incidentally is also what the testing standard calls for. All right, back to you, Sharon.
Thanks, Moses. Next question. Is the displacement value always higher than the brake force value?
Actually, that's an interesting question. So softer materials would deflect more, but not necessarily have a higher brake force. So I'll use an example. If you were pulling rubber band, even though it's stretchy and it might stretch and stretch and stretch until it breaks, it's likely not going to have that high force to break a rubber band. But if you put a stainless steel rod in there, it's not going to deflect at all by much, but then it's going to snap and you'll have a high rate of force. So in the case of catalysts and pellets, it's always going to be the hardness of the product that's going to determine how much it deflects or what force it actually breaks at. So the harder the sample, the less deflection and the higher the force, and the softer the sample, the more the deflection and the lower the force. So it's kind of opposite to your question. Yeah, softer samples would deflect more but have a lower brake force. Harder samples would deflect less and have a higher brake force. Back to you, Sharon.
Thanks, Moses. Next question. How do I know whether I require the single sample crush tester or bulk crush testing capability for my catalyst and absorbent?
Well, that's an interesting question. You probably could be able to answer that better than I can. Now, it's always going to be per industry requirement. Now, just based on my experience, most end users in your industry do both. Just so, because all you're looking to do is acquire as much data about your product as possible. So and the testing standards that I just shared, ASTM D4179 and 7084-4 also indicate the sizes of your pellets or catalysts. So for certain sizes, bulk crushing is required, and then for other sizes, the single pellet test is required. So in an industry where you have both, then the good news is the same tester can do both. You just might need to switch between different fixtures, but you can do both. But most of the time, it will pretty much be determined by the size of the samples that you're actually testing. Back to you, Sharon.
Thanks, Moses.
No problem.
I don't see any further questions at this stage. I just thought I'll give a quick reminder that our next webinar, and the last for the year, is taking place on the 21st of November, and it will focus on top load testing, so ensuring packaging integrity from production to transport. So if you would like to register for that, I am going to put a link in the chat box right now. So if you want to register for it, you've got it there. But also then just a final reminder that you've got our various email addresses on the screen. If you find that after this webinar you'd like to ask a specific question, please feel free to email us, and specifically Moses, and he will come back to you with a very knowledgeable answer, I'm sure. But that's all for us for now, and yeah, we hope to see you at one of our next webinars.
Thanks, everybody.
Thank you so much, people. I'm going to end the webinar now. Have a good day.